Hey guys, it's Raj Krishan Ghosh from Blenderphile, and today we will be talking about the normal node. So here I have a cube, a sphere and a monkey head, and they all share a common diffuse shader. Now if I press Shift A, then vector and then normal, we get the normal node. Now what this normal node does is it allows us to add fake lighting to our objects. So if I take the dot output and look at that, we see nothing. This is because we need a normal input for our normal node to work. So if I press Shift A and then add a texture coordinate and also add a geometry, you can see that there are two normal, one from texture coordinate and one from geometry. Now I will talk about both of them, but for the time being, let's plug in the normal from the texture coordinate to the normal node. Now as we see, it gives us a sort of grayscale color, and it looks like as if the light is coming from the above. Now this color can be used as a factor for a mix shader or a mix RGB or whatever we like. So I will delete this diffuse shader and add an emission shader and plug that to the surface output. Now for the color, let's first add a texture. So Shift A, texture and then image texture. Now I will add, by the way, these textures are from texture.com, and if I add the color, we don't see anything. Now change the flat to box, and we also need a texture coordinate, so we will copy this one and plug the generated input to the vector, and now we see our texture. And as this is an emission shader, we can't see any light bounces or any shadows. But if we use this normal node, we can fake the lighting as well as the shadows on this object. And as it is having an emission shader, it will render really fast and the noise will be very much less. So let's add color and mix RGB, and we will mix a white color with this image color. Now if we plug the dot product or dot output to the factor, we see that our models are now mimicking having a light source. Now at the moment it doesn't look really good, so I will add a bump map. So I will duplicate this and add this height map. Now if we plug this color to the displacement, we see that it looks a lot better than before. Now if I change the direction from this sphere type thing, we see that the direction of the light is changing, but it's not changing as like this one. It's changing in a weird way. The reason is that the rotation we see here is from the top view. So if I press 7, here we can see the dot factor is mimicking this sphere thing. Now we can adjust our lighting with a color ramp node to influence this factor. So press Shift A, converter, and then color ramp. Now if I drag this black value here, I like this color, but let's reduce the white color so that the lighting is not so sharp, and I like this color. Okay. For the next part, we will add a shadow to these objects. So we will copy this color ramp and let's see how it looks. So here we need the black colors or the shadows. So we will flip this and adjust our shader, adjust our color ramp. This looks good. Now we will add another mix RGB. So Shift D, And now we will change the color to black and add this factor to the factor input. Now if we see the emission shader, we see that we get some shadows. Now if we adjust these, we get something like this. Now let's change the direction. Okay, so as you can see, we can get very neat results and fake lighting and shadows by using this normal node. Okay, now the next thing I want to show you is that what are these two normals doing to our normal node. Now first of all, the texture coordinate normal. So if I rotate this sphere by pressing R2 times, you'll see that the light sources are sort of moving with the object. So the texture coordinate normals depend on the object rotation. If we plug the normal from the geometry to the normal node, if we rotate it, we see that the light sources are fixed in one place. So we can use whatever normal we need as per our requirement. I will delete this texture coordinate and use the normal from the geometry node, and you can see we can rotate these ones and the lighting will be fixed. Now it is for the time being affected as per the top view, but if we want it to affect from front view, we will add vector and then mapping and rotate the x value by 90 degrees, actually minus 90 degrees. Yeah, there you go. And if we press 1, we can see that the normal node is helping us to get lighting as per the front view. Now from time to time you may want to move the camera and move the light source with them. There is a trick to this. Now I will show you that. So let's delete this mapping node and plug this normal node again. Now as I said, this normal value is affected by the world coordinates. So if we rotate these models, the rotation of the normal is not changing. But if we want to change that, we press Shift A, vector, and then vector transform, and change this from world, because this normal is affected by the world coordinates. We change this from world to camera. And now we see that something weird happens. This is because the Z value is inverted. So we will correct that by changing the Z value. So now between the output of this normal transform node and the input of this normal node, we will change the normal directions. We will invert the Z values. So I press Shift A and then add a separate XYZ node and also a combine XYZ node. Now the X value will not be changed and Y value will not be changed, but we want to invert the Z values. So I press Shift A, color invert. Now if we see the Z color from here, this was it before and now it is inverted. And now if we plug the value to the Z axis, we invert the Z value. So this is our setup. And now if we plug this normal to the normal node, we can see that now the normal node follows the camera. So if we move the camera to whatever angle, the normal node follows it. Okay, so we talked about this dot factor, this normal input, and this 3D slider. Now we'll talk about this normal output. So as artists, we don't need to do anything with this output. Let's see what it looks like. So as you can see, it gives a color, and if we plug out the normal, we can see that it doesn't change. This is because it doesn't depend on the normal input. It only depends on this slider. So if I change the slider, you can see that its color is changing. Now what actually happens here is that this normal input and this normal, which is shown by this color, is operated upon by an operator known as the dot product. So this dot factor is the output of the dot product of this normal and this input normal. Now this changing of the slider change the color. This vector is actually dependent on this slider. So if we change the slider, the vector direction changes, so the dot product correspondingly changes. But we don't need to care about that. Only the dot product is our need. So this is our output, and let's change the direction. Yeah, so that's all about this tutorial, guys. Thanks for watching. Bye.